So the objective of this restoration is that I have to estimate that f hat x comma y of the original image f x comma y, right? So to make it more clear, I just gave you an example that let us just assume this degradation function which I'm talking about is your averaging filter. Then I added some noise. Okay, one more example just came to my mind. Supposedly that okay, I have done that thing that I have added the degradation function, which is my averaging filter, say, and then there is an image like this is the image, right? Just this thing is an image, and you just see certain like dots into this, not this line. I have just drawn that line by mistake. So they are just like this white and black dots, right? Here you're just it's just red dots, but assume that there's an image and I'm just getting certain black and white dots. So that is nothing but there's one noise which has been added to it, which is called impulse noise or salt and pepper noise. Like salt is of white color and pepper is of black color. So that is what has just happened, that we have just added this salt and pepper noise into it, and that is the final degradation which I have done. And to restore it, I'll be having certain restoration filter. So my objective is that I have to estimate this thing so that I get it closer to this thing. And here it is written that we want the estimate to be as close as possible to the original input image. And in general, more we know about H and N, the closer f hat x comma y will be to f x comma y. That is what I said to you, the analogy. Remember the analogy? More that person knows that how that you know like how the earthquake destroyed it. So similarly over here we'll just say that more you know about the H and N, you will be having the f hat x comma y more closer to f of x comma y, right? So it's all about the knowledge. More knowledge you have about these two things, H and N, more you will be able to bring your f hat x comma y closer to f of x, and you have complete knowledge perfectly same as f of x comma y, right? But it's a bit difficult task because you just know that original image. So definitely you have this thing, degraded image. If you know this, definitely you'll be getting this. This is a simple mathematics thing. It's not a rocket science to understand this, right? So this was the basically the equation in the spatial domain. This is the equation in the frequency domain, but generally in I'll be dealing with spatial domain only. I won't be teaching you the frequency domain, but in one thing which I can tell you over here, how this equation changed from this to this. The noise will simply remain additive. There is nothing change in this. This is also the degrade. But one thing which has changed is that if you see this term over here, Fourier transform, Fourier transform, Fourier transform, I mean the Fourier transform. So these all are done the Fourier transforms, because in the frequency domain we basically deal with the Fourier transformation of the things, right? Noise, as I always said, it will remain additive. It will remain additive, right? So here, there it was convolution, right? So I just tried here it was convolution. So here it was convolution, but here if you see, here it is simple multiplication going over here, because what happens is that whatever, if in the spatial domain it's convolution, it will be multiplication in the frequency domain, and in the frequency domain if it's a multiplication convolution, it will be multiplication over there. So whatever is multiplication becomes convolution, convolution becomes multiplication. These things goes on during in frequency and the spatial domain, right? So okay, we have up till now did a very good thing about the introduction and good deal of introduction. So here they say that some restoration techniques are best formulated in spatial domain while other best suited for frequency domain. That is a very perfect thing. Like supposingly if you are making a house, so consider that one is internal architecture and one is the external architecture, right? So if I'm restoring, say, external things, right? So I'll be contacting someone who just do the exteriors better. If I'm restoring the interior thing, I'll say that okay, let's just call the interior one, he'll do it better. So it's not that the exterior designer cannot do interior designing, he will be able to do, right? But it's all about what is more good, what is best formulated. So it's not that if you're applying any image and it will not give you good results in spatial frequency domain. No, spatial and frequency domain will both give you good results, but there are some restoration techniques which are best formulated in spatial domain, while others are best suited for the frequency domain, right? Like for example, if you see that, for example, the spatial processing is applicable when only degradation is the additive noise. Like if you uh, don't have that function, right? Like if you simply had g of x comma y, just mind this ink annotations, right? I'm not able to write it as of now. So just if I have g of x comma y is equal to f of x comma y plus the that noise term, right? Just complete it with the like yourself, right? This is like the noise one, right? So if this happens, just the noise, it's not having h into it, right? So spatial processing will perform very good, believe me. Other hand, the degradation such as image blur is best handled in the frequency domain. So while dealing with degradations only due to the noise, we assume that H is my identity, which means H is a 1. So convolution will 1, like, so here it's identity, it's 1 over here, right? So doesn't make any sense anyhow, right? So just need to keep in mind that since we'll be talking about only spatial domain, so you'll be seeing this equation mostly, right? uh, we are not dealing with frequency domain, so this lecture series which I'll be even uploading further will not be able to handle the image blur case, right? Because that is best handled in frequency domain. We'll be just able to see what goes over here, this thing, right? So just wait a minute, you'll be just knowing what equation I'm talking about. Yeah, this is the equation I'm talking about. So this is what will be handled in my spatial domain, right? So this is what will be handled in my spatial domain, that we'll be having that H operator as identity.